All right, next up, we're going to talk about the molecular equation and ionic equation, right? And why they are important, especially the ionic equation is really important. Before that, let's take a look at this overall reaction. This is a precipitation reaction of silver chloride, right? Sodium chloride, silver nitrate, silver chloride precipitate out of the solution. You saw it in the previous video. All right, now, but in the solution though, what's going on into the solution? Well, in solution, sodium chloride is soluble in water, so it won't stay as sodium chloride. Does it make sense? This is just the overall reaction, but it doesn't tell you what's really happening in solution. In solution, sodium chloride doesn't stay as sodium chloride. It's not lattice anymore. It show up as sodium ion and chloride ion where water is surrounded. To represent that, we write like this. We break them up: sodium ion, chloride ion, aqueous. See that? That's what happened in the solution. They don't stay together as sodium chloride lattice. It's just two ions separately. All right. Silver nitrate also soluble in water, not solid. Here this is aqueous. So which means that in solution, silver ion and nitrate ion are floating around separately. Okay, so I'm showing what's going on in the solution now. Now, silver and chloride floating around and see each other, positive, negative, they attract, of course. And when they attract, when they stick together, they realize that, oh, they're not soluble in water. The attraction is better than the attraction between silver ion and water or chloride ion and water. Stick together, they feel better. They feel more comfortable, more stable. So in the product side, I'll take a look. Sodium nitrate still floating around in the solution is aqueous, but silver chloride, they stay together. All right. The top reaction here, we call this a molecular reaction, showing what's going on, the overall reaction, what's happened. But in the next, the bottom reaction, that is an ionic equation. Right? Ionic equation shows what's going on in the solution. In solution, sodium ion, chloride ion, they don't stay together. Silver ion, nitrate ion, they don't stay together. The product as well, sodium nitrate, they don't stay together. They are in the solution floating around, right? But silver chloride, they stick together, solid right there. This is ionic equation, show all ions, all right? Now, if you look at the this ionic equation, all right, you're gonna see this sodium ion on the left side, sodium ion in the product, nitrate ion on the reactant side, and the nitrate ion in the product. These guys show up on both sides, which means that they don't do anything in the reaction, right? They just show up in the reactant and then show up in the product. Well, you actually don't do anything here. Well, this is an equation. If something that doesn't do anything, we can cancel them out. So the real reaction is actually, here we go, we call a net ionic equation. Chloride ion, silver ion combine, you get silver chloride as a solid precipitate. Okay, the species that does not participate in the equation, in the reaction, we call them a spectator ion. Like you go to like a concert, you go to a football game, a baseball game, you are a spectator. You don't actually participate in the sport or in the concert. You don't like actually sing on the stage, or you don't like really tackle anyone on the field, right? So you are a spectator. So they don't do anything in the event. Same thing here, spectator ions. They don't participate in the reaction, so you can cancel them out, and you will get to the net ionic equation. What really happening in the solution, basically. This is really important because it tells you what's going on in the solution. Okay. All right. So we have molecular equation, which shows the overall reaction. We have ionic equation, show what's going on in the solution. They become ion, they become ion, they become ion, or they precipitate out. And the net ionic equation actually that show actually what happening. So just silver ion, chloride ion to make silver chloride. That's it. Okay. All right. Now your turn. All right. So when lead nitrate and sodium iodide are mixed, a yellow precipitate is formed. Write a balanced equation. All right. All right. Check with me on the next video.